Math 1332, Chapter 10, Probability and Counting Techniques. Section 5, Probability using Permutations and Combinations. Video 2, Probability using Combinations. Just like in the previous video, we're going to be calculating probability. This time, it will be using combinations. Of course, you know that in advance because I just said it, but when you see an actual problem, you still have to ask yourself, are we dealing with permutations or combinations? And remember what separates the two. A permutation is an arrangement of objects where order matters. A combination is an arrangement of objects where order doesn't matter. You can also think of as a permutation as making a sequence of choices in a particular order, whereas a combination, you're just selecting a bunch of things at one time without regard to the order. Let's take a look at this example, which actually has 3 parts. In a company, there are 9 executives, 6 women and 3 men. 3 are selected at random to attend a management seminar. A, find the probability all 3 selected will be women. Round your answer to 5 decimal places. All right, well, let's start by posing the question. Probability that we select 3 women. And remember the definition, or rather the formula for theoretical probability. The probability of an event occurring is the number of outcomes in the event divided by the total number of outcomes in the sample space. But what does that mean in this particular problem? Well, the desired event that we're looking at is the probability that we select 3 women. So the numerator of our fraction is going to be, oh, by the way, does it matter which order we select the women in? It does not. It doesn't matter if we say Alice, Beth, and Christy, or if we say Christy, Beth, and I forgot what the first Alice I said, I think. It doesn't matter what order we select them in, which means we're looking at the number of combinations. So the probability that we select 3 women is the number of ways to select 3 of 6 women. That will be our numerator. Give me a second to draw a fraction bar. Well, I'll draw the fraction bar in a second. And our denominator will be the number of ways to select 3 out of 9 people. Because the denominator, the sample space, is the total number of ways that we can select 3 people. Our specific event is the number of ways to select 3 women. Let's draw that fraction bar in the middle. There we go. So again, the numerator is just the desired event that we're looking for. We want to select 3 women out of the 6. 1 second, folks. There we go. The syntactic imbalance between the 2 sides of the fraction was driving me crazy. Select 3 out of 6 women, select 3 out of 9 people. OCD. All right. So for our numerator, we need the number of ways to select 3 out of 6 women. And again, it's a combination, so we don't have to worry about the order. Well, we don't have to worry about the order, so it's combination. And we'll switch over to drawing now. The number of ways to select 3 out of 6 women is going to be 6C3. Again, combination because the order doesn't matter. The number of ways to select 3 out of 9 people is 9C3. Let's work out both of these. And we'll work them out separately, and then we'll put them back into a fraction. 6C3, the formula for combination says first number factorial on top, second number factorial on bottom, and the difference factorial, but the difference happens to also be 3. Let's spread this out and see what happens. On the top, we'll start expanding the 6 factorial until we get to the larger of the 2 factorials on the bottom, but they're both 3. Normally I would use ellipses, but there's only one number between 3 and 1, so there's really no need for ellipses there. In the denominator, we have 3 times 2 times 1, twice. And let the canceling begin. The biggest chunk we can cancel is 3, 2, 1. Of the remaining numbers in the denominator, 3 times 2 collectively make a 6. So we can cancel out the 3 and the 2 at the same time with the 6. That leaves only 1 in the denominator, which means it's not really a fraction anymore. 5 times 4 in the numerator, that's just 20. The top of this fraction is 20. Well, the top of the original fraction that we're working out. Now let's look at 9C3. 9 factorial over 3 factorial, and then the difference factorial, 6 factorial. We'll start writing out the 9 factorial until we get to the larger of the two numbers on the bottom. 9 times 8 times 7. And there's the 6. Time for ellipses all the way down to 1. In the denominator, we have the 3 factorial, 3 times 2 times 1. And we have the 6 factorial, which we don't really need to write out because we know that we are about to do this. Unlike the previous one, we can't cancel out the 3 and the 2 simultaneously because there's no longer a 6 in the numerator, but we can cancel them individually. This 3 will go into this 9 3 times. This 2 will go into this 8 4 times. Let's carefully gather up the pieces that remain. Only a 1 in the denominator, so we're good there. In the numerator, we have 3 times 4 times 7. 3 times 4 is 12, and 12 times 7 is 84. So the denominator of our fraction is going to be 84. Our probability is 20 over 84. We are, however, asked to round this answer to 5 decimal places. So let's go to a calculator and see what we see. Where'd my calculator go? All right, 20 divided by 84 has a lot of decimal places. We're going to round to 5, so let's go to 5 and look at the 6th. 0.23809, and then the next digit is 5. 238095. Actually, let's go back to the board. 238095. And let's clean this up. The probability is 0.238095. And after looking at the decimal a little more closely, I realized it was that 6 digits repeating as a block. But we're being asked to round this to 5 decimal places. So just a reminder how to do that. We look at the first 5 decimal places, so 23809, go over 1 spot, and then decide what to do based on that digit, whether or not it's 5 or greater. That is 5 or greater. And when the next digit is 5 or greater, that means that you round the 1 to the left of it up by 1. But the 1 to the left of it is 9. It would round up to 10, which means that, that this would go up to 10. Just think of it as an odometer, and that 09 would roll up to the next digit, which would be 10. So our desired probability is 0.23810. All right, that wasn't too bad. Let's take a look at the next one. Find the probability 2 women will be selected and 1 man will be selected. Round your answer to 5 decimal places. All right, this one takes a little bit more work. Let me pause and go and get the probability typed. The probability of selecting 2 women and 1 man will be the number of ways to select 2 out of 6 women and 1 out of 3 men. Because remember, I believe there were 6 women. Yes, 6 women and 3 men. The number of ways to select 2 out of 6 women and 1 out of 3 men. That's the event that we're looking at. And the sample space is the number of ways to select 3 out of 9 people. The numerator is going to be a little trickier to figure out, but this is where we have to go back to the fundamental counting principle. We need to select 2 women. We need to select 1 man. We have 2 decisions to make. Fundamental counting principle says figure out the number of ways to make the first decision, figure out the number of ways to make the second decision, and then multiply them. Let's focus on the numerator. The number of ways to select 2 out of 6 women and 1 out of 3 men, not sure why the comma disappeared, so we'll just draw that in, is a fundamental counting principle problem. How many ways can we select the women times how many ways can we select the men? Those look like fraction bars and they're not, so we'll get rid of them. How many ways can we select 2 out of 6 women? And remember, the order doesn't matter. 6C2 is the number of ways we can select 2 out of 6 women. How many ways can we select 1 out of 3 men? 3C1. For the sake of time, I'm not going to evaluate either of these combinations. I'll leave it up to you to justify that these are the correct values. But 6C2 is 15, and 3C1 is 3. Meaning there are a total of 45 different ways to select 2 out of 6 women and 1 out of 3 men. There's 15 ways to select the women, 3 ways to select the men, and the fundamental counting principle says, therefore, there are 45 ways that we can select 2 women and 3 men. That will be our numerator. Let's write it above the fraction. The denominator is going to be easy. The number of ways to select 3 out of 9 people is exactly what we did here. And therefore will still be 84. So there's no need to reinvent that wheel. It was the numerator that was causing trouble this time. We end up with 45 out of 84, and we're being asked to round it to 5 decimal places again. Let's clean this up and figure out what that is. The first 6 decimal places of 45 divided by 84 are 0.535714. The reason I took it to 6 is because we are rounding to 5, which means we have to look at the 6th decimal place to decide how to round. Since the 6th decimal place is less than 5, we do not round the numbers in yellow up, we leave them alone. And so 0.53571 would be our probability. So there's a better than 50% chance that we would randomly select 2 women and 1 man out of the 6 women and 3 men. We do have one more part to this problem, but it's a real easy one to answer because it's based on the first 2 parts. Find the probability that more women than men will be selected. This may sound tougher because it doesn't give a specific number, but let's think about it. The probability that you select more women than men I'm going to write it down here because I know I'm going to run out of room. We're picking 3 people. So if we pick more women than men, how could that happen? We either pick 3 women or we pick 2 women and 1 man. Those are the only ways we can pick 3 people and have more women than men. Because if we don't pick 3 women or 2 women, then we can either pick 1 woman, which would mean 2 men, that's not more women than men, or 0 women and 3 men, which is clearly not more women than men. We've already done both of these problems. The probability that we select 3 women, that was the first part. And we've already done this problem, the probability that we select 2 women and 1 man, which was this part. The only thing we really haven't talked about is what to do with this or. Without getting into an entire lesson, when you see the word or in a probability problem, it usually means to add. The probability of this happening or this happening is the sum of their probabilities. There are exceptions to that, but we're not going to run into those exceptions. The probability that we selected 3 women at random was 0.23810. The probability that 2 women and 1 man was selected was 0.53571. And now we just have to add 0.53571 plus 0.23810 is 0.77381. Out of all the things that happened in this video, I think this one is probably the one that you really need to focus on the most, because the first one was really like the previous video where you had one permutation over another. It's just in this case, it was one combination over another. But this one is where we really had to put a lot together. There were 6 ways to choose 2 women, the number of ways to choose 2 out of 6 women was 62 times the number of ways out of 3 men to choose 1. And then the denominator, of course, was out of 9 people, the number of ways to choose 3. So that should really be your focal point on this video.